Hello everybody. Welcome to Creating the Basic Adaptable Game Engine Library Part 2, Triangle Math. In the previous video, we talked about some of the core classes we will need to create in order to create our first simple example of a game called Starfish Collector. One of the first classes we'd like to create is something called the vector class, which can be used to store position and velocity and all sorts of other useful information. But in order to write some of the functions for that class, we're going to need a little bit of mathematics to help us along the way. And so this video is a quick review of some fundamental mathematical formulas which we're going to use in the near future when we create the vector class. So most of the math we need to review has to do with triangles, specifically right triangles. Let's assume you have a right triangle, as shown in this diagram, and the hypotenuse, which is the side opposite the right angle. The hypotenuse, we'll say that has length c. And then the other two sides of that right triangle, let's say they have lengths a and b. The Pythagorean Theorem is an equation which relates the lengths of the sides of that triangle. Specifically, it says in a right triangle, a squared plus b squared equals c squared. Also, something which will be important in the videos which follow are some of the basic trigonometry functions. Again, assuming we have a right triangle with a right angle, let's say we're interested in one of the other angles, this angle that we're highlighting right here. Let's call that angle theta. Again, the side opposite the right angle is called the hypotenuse, but to distinguish the other two sides, we'll call the side next to the angle the adjacent side, and the side opposite the angle of interest, well, we'll call that the opposite side. And there are some trigonometric functions which relate this angle to ratios of these sides. Specifically, the sine function, sine of theta, is defined to be the length of the opposite side divided by the length of the hypotenuse. The cosine function is defined to be the length of the adjacent side divided by the length of the hypotenuse. And the tangent of that angle is defined to be the length of the opposite side divided by the length of the adjacent side. Now, these will become very useful because often when we're given some information about a triangle, we'll want to learn about other parts of that triangle. In particular, for this right triangle, the four items which are of interest are the lengths of the sides A, B, and C, and this angle theta. Given two of these values, we can use these formulas, the Pythagorean Theorem and the trigonometry functions. Given two values, we can use these formulas to solve for the other two values, just by rearranging these formulas. For example, let's say that you know the length of the side A, the adjacent side, and the length of the opposite side, B. We can use that information to solve for the length of the hypotenuse, C. That's the square root of a squared plus b squared. We can also solve for this angle theta using the tangent formula. Here, I'm replacing opposite with b and adjacent with a. To isolate theta, we have to undo or invert the tangent function, and that's called the arctangent function, or in computer programming, it's usually a tan. And so theta is equal to the arctangent of b over a. One thing to keep in mind, these functions usually require radian measure. So given a and b, you could solve for c and theta. Similarly, if you're given the angle theta and the length of the hypotenuse c, you could solve for a and b, once again by rearranging these formulas. If you take the formula for cosine, and I'm replacing the adjacent side and the hypotenuse by a and c, you could actually solve for the adjacent side a by multiplying both sides by the hypotenuse c, and you're left with this formula. A equals c times cosine of theta. Similarly, the formula for sine theta, that's opposite over hypotenuse. Let's think of that as b over c. You can solve for b, multiplying both sides by the hypotenuse, and you're left with this formula. B is equal to c times sine theta. Right? So with this information, if you know the values of c and theta, you can use these equations to solve for a and b. And these facts are going to be very useful to us when we start talking about points and vectors, and we'll talk about the math involved with those in the next video. Thanks for watching.